Hello students, today's topic is metallurgy. In metallurgy, we extract metals from certain minerals. Metals exist as minerals in the earth's crust, and from where we are going to extract the metals. But just before we move on to the techniques involved in this metallurgy, we will first see what metals are, how different they are from non-metals, and what are metalloids. Now, in the periodic table, there are close to 120 elements, slightly less than 120 elements, most of which are metals. For example, in the periodic table, there are 4 blocks. There is an S block, there is a P block, there is a D block, and there is an F block. S block is full of metals. D block is full of metals. The F block is also full of metals. And within P block, we will find non-metals, we will find metalloids, and there are also a few metals, which means that metals are close to 75% or slightly more than 75% of the entire elements that we have. In metals, the very common ones we have seen are copper, silver, gold, we may have nickel, platinum, iron. So, like this, there are a variety of metals with varied usages. Next, non-metals, we have oxygen, we have sulfur, we have phosphorus, we have nitrogen, we have fluorine, we have chlorine. So, like this, we also have quite a few non-metals having different uses. Then in metalloids, metalloids are elements whose characteristics are in between those of metals and non-metals. For example, we may have a germanium, we may have an arsenic, we may have an antimony, we may have a silicon. So, like this, there are a few elements which have intermediate characteristics between that of metals and non-metals. So, these are metalloids. Now, we will see the differences between metals and non-metals in general in terms of physical properties and chemical properties. So, in the physical properties, we have taken here physical state, that is the appearance, melting points and boiling points, hardness, density, and then conductivity. When we say conductivity, it is electrical conductivity. Now, physical state, the metals are usually solids. What I have shown here is that there are exceptions. For example, we know that mercury is not a solid. Even cesium, for example, even gallium, they are not solids. They are close to 30 degrees. Cesium and gallium melt at 30 degrees. So, they are also considered to be liquids along with mercury. Now, non-metals are usually gases. Exceptions, we can say, for example, phosphorus is a solid, sulfur is a solid, carbon is a solid. So, like that, we have exceptions. Then melting points and boiling points are usually very high for metals, but exception again. Even sodium, even lead have low melting points. Zinc has got low boiling point. So, like this, there are exceptions. In non-metals, we usually find that the melting points and boiling points are high. Again, an exception here is the diamond form of carbon, the boron form. Boron is a non-metal, but still it has got a very high melting point. Next, coming to hardness, metals are usually hard, but we know that alkali metals, for example, lithium, sodium, and potassium, are very soft. They can be cut with a knife. And among non-metals, we have solids which are brittle. Again, an exception here is diamond, which is very hard. We also have a form of boron called borazone, which is also exceptionally hard. So like that, we have exceptions in all these physical properties. Density usually for a metal is high. Again, we have the same elements, lithium, sodium, potassium, having very low density. For example, lithium and sodium, even potassium, float on water. Means the density is less than 1 gram per cc. Next, density for non-metals usually low. Again, an exception is diamond. Then among conductivity, metals are usually good conductors. Exception is tungsten, which is used as a filament element. Then non-metals are usually bad conductors. An exception is graphite. Graphite is a good conductor. So these are all the usual things happening, but there are exceptions. We'll see a few more physical properties. Next, we'll move on to luster. We know that metals are having a shine, so they are lustrous, whereas non-metals are not lustrous, except, for example, you can take graphite, also iodine. So these are exceptions under non-metals. Then tensile strength, metals have high tensile strength, whereas non-metals usually do not have tensile strength. Exception in this category is carbon fibers, which have been discovered recently. They have got good amount of tensile strength. Next, malleability and ductility. Malleability means being able to, what shall we say, put in the form of sheets, and ductility is drawn into the form of wires. So we can make sheets and wires out of metals. That is why they are malleable and ductile. Whereas non-metals are usually not malleable and ductile. Exception here is the same carbon fibers, which is ductile. You can make wires out of carbon fibers. Next, sonorous nature. The sound they produce is found for metals and usually not found for non-metals. Next, occurrence, how a metal is occurring in nature. A metal may occur in the free state or in the combined state. For example, here we may have gold in the free state, and we may have sodium in the combined state. For example, sodium may exist as Na2CO3. Similarly, non-metals can also exist in free and combined state. For example, sulfur or diamond, they exist in the free state. They are also existing in the combined state. For example, you may have H2O is in the combined state. Next, atomicity. Now, how many atoms are there in a molecule? For metals, it is usually monoatomic. An exception is gallium. Gallium exists as a diatomic species, that is Ga2. Non-metals are usually diatomic, triatomic or polyatomic. For example, diatomic means we can use O2. Triatomic, we can use O3. Polyatomic, we can use say S8, P4. So like this, we have diatomic, triatomic or even polyatomic. There are also monoatomic. For example, the noble gases, helium, neon, argon, etc. These are all monoatomic. So like this, the atomicity for non-metals is usually varied. Next, when it comes to alloy formation, what are alloys? Alloys are solutions in the solid state. Means they have got mixed in the molten state, that is in the liquid state, and then they have got solidified. Now, metals usually give alloys, whereas non-metals are not giving alloys. And we have an exception here. For example, carbon is used in steel. Steel is an alloy. So there are a few non-metals which are also included in alloys. Next, solubility. Metals, when they are found to be soluble, they have undergone a chemical reaction. For example, if you have Na, Na would react with H2O and would finally give NaOH, and this NaOH which is there in the soluble form. Whereas non-metals do not undergo any chemical reaction. For example, oxygen would dissolve as it is. Nitrogen would dissolve as it is. A few exceptions are still there. For example, if you take non-metals, of course, we may have a few substances which may have an affinity for water, but usually the compounded forms are having chemical reaction. For example, carbon dioxide would mix with water to form H2CO3, but of course this is for a compounded form, not an elemental form. So usually non-metals do not undergo a chemical reaction, whereas metals undergo a chemical reaction and then become soluble in the given solvent, usually water.